Good morning, children. Today in Zoom class, I started with B part electromagnetic spectrum and its broad classification. Today, we'll be completing this part because many students did not attend the Zoom class. I thought of giving a recap of what we did during the Zoom class, and then I'll do the rest of the part. Okay, so as I told you, or um, we know that so far we've been seeing that whenever white light falls on a prism, it splits into 7 colors. 5, 6, 7 on the first surface. Splitting and bending both occurs, dispersion and deviation, and on the second surface only bending occurs. So this is what we studied in the A part. Okay, and the colors are like this. Okay, now actually above red and below violet also there are some band of radiations which are not, this is the visible part. Okay, this is the visible part, so we are able to see this, but there are some radiations which are invisible to human eye, but they are present. There are different ways to detect them. Okay, so and the whole thing is called electromagnetic spectrum. Okay, now above red we have infrared, and then microwave, and then radio wave, and below violet you have ultraviolet, X-ray and gamma rays. Okay, so below violet there are 3 rays, and above red there are 3 rays. So this is the whole thing together. Now hereafter, when we talk about the whole spectrum, we will not write all the colors, we'll just call it visible spectrum. Okay, so radio wave, microwave, infrared, visible, then UV, X-ray, gamma. Okay, now the order is very important. Okay, the whole thing is called electromagnetic spectrum. Okay, radio wave, then microwave, infrared, visible, UV rays, X-ray and gamma rays. So these are the 7 rays in the electromagnetic spectrum. Now the order is very important. Now you can rate either in increasing order of wavelength. If they ask you to write in increasing order of wavelength, you have to write from below. If you remember, even in the visible spectrum, violet has smaller wavelength and red has the maximum wavelength. What does it imply? From down to up, wavelength is increasing. The same will be true for the whole spectrum. Wavelength increases from down to up. So if they ask you an increasing order of wavelength, gamma will come first. Okay, so you will write gamma first, followed by X-ray, followed by UV, followed by visible, IR, microwave and radio wave. Okay, and this will become decreasing order of wavelength. So usually they ask you to write all the waves in the electromagnetic spectrum. They ask you to write either in increasing order of wavelength or decreasing order of wavelength. Now remember any one thing. You remember like this: down to up, increasing order of wavelength, gamma, X-ray, UV, visible, IR and microwave and radio wave. Now there is another possibility with respect to frequency also they can ask. Okay, you know that lambda and frequency are inversely proportional. So if they ask you, this can be decreasing order of wavelength or increasing order of frequency. increasing order of frequency. This can be increasing order of wavelength or decreasing order of frequency. Okay, children, you remember any one thing. Don't try to remember all four things and end up confusing. You remember one thing. I would suggest increasing order of wavelength you remember. Then automatically the other three you will be able to write it if you know the logic that lambda, frequency and wavelength are inversely proportional, and down to up it increases. Is it clear? Okay. So this comes in a 2-mark question. Write the complete electromagnetic spectrum in increasing order of wavelength or decreasing order of frequency, like that. Okay. Now you don't. They all have a particular range of wavelength and frequency, but you don't have to memorize these numbers. You don't have to memorize. Just the order is important. Okay. Now the note here is important. Although we show sharp boundaries, there are actually no sharp boundaries. They will be overlapping each other. Okay, here you will see some gamma, here you will see some X-ray, like that. Okay, infrared is beyond red, ultraviolet is beyond violet. Now this table gives okay, so actually no question comes from this. If you want to study for extra information, you can study. Even ranges of wavelength you need not study. Come straight to this one. Properties common to all electromagnetic waves. Okay, like sound wave, light wave, electromagnetic waves are also having some properties. What are they? They do not require any material medium for propagation. Okay, that's the reason why sunlight is able to travel through space and reach the surface of Earth. They all travel with the same speed in a medium. Okay, electromagnetic waves, the frequency, wavelength and all may be different, but the speed is the same. Speed in air or vacuum will be same as that of light, 3 into 10 power 8 meter per second. Then they exhibit the property of reflection and refraction. Like sound, light and everything, they also can exhibit reflection and refraction. Fourth point is, these waves are not deflected by electric and magnetic field. Okay, even if you pass them through electric field or magnetic field, they will not be deviated. These waves are transverse in nature. Okay, you remember transverse wave? Last year you studied, in which the vibration of the medium particles is perpendicular to the direction of propagation of wave. Wave will go like this, but the medium particles will be vibrating like this. You will get a sine wave kind of a thing. So it is a transverse wave. Okay, now you can strike off gamma, X-ray and all that. In syllabus, we have to study in detail about UV radiation and infrared. So you can strike the rest of the ones. Now, UV radiation, again, you don't have to study all this. Come straight here. Sources of ultraviolet radiation. Where do we, what are the various sources of ultraviolet radiation? Sun is the natural source. Ultraviolet can also be produced artificially. What are the ways? First one, electric arc and spark. Okay, electric arc and spark used in welding and all that. It gives electromagnetic radiations. Okay, and you know that UV radiations are harmful for eyes, for skin, etc. That's why while welding, people use a protective shield in front of their eyes so that it doesn't harm their eyes. Second one, mercury vapor lamp. Okay, this is the lamp that is used in big stadiums and all that. It can light a wider view. Okay, wider area it can light. Okay, those yellow color lights which you see, it can show up to a long distance. Those are mercury vapor lamps. They also can emit ultraviolet radiation. Third, sun is the natural source of UV radiation. So we have three sources, 1, 2 and 3. Okay, fine. And then properties of UV radiation. Now, because we have studied already there are some properties which are common for all radiation. So I'm leaving those properties and doing only those that are unique, that is only for UV radiation. Okay, one is the first one. UV radiation can pass through quartz, but they are absorbed by glass. Now, if I allow sunlight to pass on it, and in this spectrum, I can't get UV by passing it through a glass prism. I can't get UV radiations because glass absorbs UV radiation. Ordinary glass absorbs UV radiation. There are special glasses. So quartz is a special type of glass which are used in clocks and all that. Now, so these ones do not absorb UV radiation. So if I want to UV radiation to come here, I instead of using an ordinary glass prism, I should use a quartz prism. Then only I'll get UV radiation. Okay, so um, for the same reason, the UV bulbs have the envelope made of quartz instead of glass. Okay, the second unique point is they're usually scattered by dust particles present in Earth's atmosphere. They are scattered by dust particles. Third one, they strongly affect photographic plate. They are chemically more active than visible light. Compared to visible light, they are chemically more active. Now, photographic plate means, you remember in earlier days before this digital one came, we used to have those films, photographic films, which is black in color. Used to have this reel kind of a thing. Okay, and so there will be a roll on which um, each one you can click a picture and it will be stored in the one, then the next one, then the next one, like that. And after you're finished, now every roll will have some 32 or 34. You can take 32 or 34 snaps. After that, you have to give it in a um, developing photographic developing studio kind of a thing, where they will develop and get you the hard copy of the photographs. Okay, so that's called the photographic film. Visible light itself will be very reactive. More than that, UV will be more reactive. Okay, so it's a property. They strongly affect photographic plate. Then they produce fluorescence on striking a zinc sulfide screen. If UV rays are made to strike a screen that has zinc sulfide on it, then it will illuminate. Wherever it hits, those parts alone it will illuminate. Okay, so then coming to harmful effects. Harmful effects, they can cause skin cancer if it is exposed, if a human body is exposed to them for a long period. Then uses of UV radiations, they are used for sterilizing purpose. So what is sterilizing? Sterilizing means um, making anything free of germs and other things. Okay, any microorganism. So even in medical purpose, suppose you got a wound there, using a gauze um, to put a bandage, those gauze and everything will be sterilized. Okay, they'll make sure that that is free of any germs. So that is called sterilizing. Then detecting purity of gems, eggs and ghee. Okay, gems, you know that gemstones, eggs and even ghee's purity can be checked using UV rays. In producing vitamin D in food of plants and animals. Okay, these are used in special conditions, and we don't use it normally in our day-to-day life, but they are used in for industrial purposes. Okay, now you can strike off visible light. We have to study infrared, but not these ones. Let's go straight to sources of infrared radiations. Okay, you can leave this. Visible, we have studied already quite a lot. Start from here. Sources of infrared radiations. All red hot bodies such as heated iron ball, flame, fire, etc. are sources of infrared radiations. Any red hot body. You take a um, iron rod and keep heating it till it becomes red hot, then it starts emitting infrared radiations. Okay, flame, fire, everything are sources of infrared radiation. Then as usual, sun is the natural source. This is the artificial source and this is the natural source. Now properties. Now infrared properties are very important and it has lots of applications. Okay, so pay attention. They travel in straight line like light with a speed equal to, these are the common points. Let's come to those unique points, the ones that are unique for infrared. One is they do not affect ordinary photographic film. It's just the opposite of UV. In UV, we saw they affect the photographic film more than ordinary light, whereas infrared lights, they do not affect the ordinary photographic film. However, a specially treated photographic film is affected by them. Now, this property of it is used in this application. Now, when I was talking about this film and developing, it's very important that they develop it in a dark room. They develop it in a dark room because light can affect now basically what would have happened, the suppose if I clicked a picture of a circle, so only this part will be lighted and other in other parts the chemicals would not be reacted. Okay, but so if I while developing also they'll make sure they keep it in the dark room so that only this part, the part that has been captured while taking photograph, only that comes significantly in the photograph. Okay, so they have to do it in dark room. Now in a dark room without any light, it's very difficult, right? You can't do work in a dark room. They need some light, but it should not be reactive. So what do they use? They use infrared lamps. So the question is, why are infrared lamps used in dark room for developing photograph? Answer: because they provide some visibility. Remember, infrared lights won't be very bright. They can provide some visibility without affecting the photographic film. At the same time, they won't affect the photographic film. Okay, these films are so sensitive to visible light. So if I just pull out one film and just expose it, I can't use it again because the whole thing will be reacted, means visible ray would have, sunlight would have activated the whole thing. You can't use it. So specifically they use infrared lamps in dark rooms for developing photographs. Okay, so okay, so if this comes in, so I have put in reasoning. These are three important reasoning questions that's asked very often. Second one, the other property is they are absorbed by glass but they pass through rock salt. UV can pass through quartz prism and IR can pass through rock salt prism. We have a, rock salt which you use for eating purpose, but there is a stone also, rock salt stone, and a prism then can be made of that. Okay, then third one, they are detected by their heating property using a blackened bulb thermometer. Okay. Then they are scattered less by Earth's atmosphere. Now, another unique property of infrared radiations are they are scattered very less. Scattered means they don't get deviated. Okay, here and there they don't go. You send it in a direction, it goes straight in that direction. Okay. Why is it so? Because of their long wavelength. Okay, so it is in the increasing order of wavelength. If you write, yeah, it is in the higher order of wavelength because its wavelength is more. Now this is in the C part and for, it has been cut, but you just have to know this because yeah, scattering is inversely proportional to lambda power 4. That means any wave that has more wavelength gets less scattered. The waves that have less wavelength gets more scattered. Is it clear? So that way, when you compare to all this, IR is having a higher wavelength, so it gets scattered very less. You send IR rays in a particular line or a particular direction, it goes without getting scattered. Okay, now where is this used? Now this can be a reasoning question. Why are infrared radiation scattered less by Earth's atmosphere? So the reason will be because they have a long wavelength and we know that scattering is inversely proportional to lambda power 4. So therefore they don't scatter much. Now where is this used? This is used in this one. They are used in photography at night and also in mist and fog condition. Taking a photograph in mist and foggy condition is very hard. Nowadays, we have um, in the mobiles and other things, DSLR and all those, they have features to take in mist and fog. But earlier, they didn't have that. So they used to use IR radiations. Okay. So to take photography at night and misty and foggy condition, the flashlight that they use, they won't use a ordinary light, they use a infrared light, because that can penetrate into the, they're not much scattered, so they can penetrate appreciably through it. So if they ask you why are infrared rays used in photography at night and mist and foggy conditions, answer, they are not much scattered, so they can penetrate appreciably through it. Another one major advantage is they are used as signals during war. Okay, the best thing is it is not visible, it's very dim, but it can penetrate through a medium very, it can highly penetrate through a medium. So what they do is during war and all signaling purpose, they use infrared radiations. They are not visible and they are also not absorbed much in the medium. Okay, so you send it in a particular direction, it will go, and whatever work has to be done, it will do. At the same time, it is invisible, so the enemies cannot see it. So it is used as, so these three are some of the common reasoning questions. Now, apart from that, infrared radiations are used for therapeutic purposes by doctors. You would have seen some people who go for physiotherapy and all that. After a fracture or something, you need to go for a physiotherapy because your muscles and bones have got stiff because of that cast. So in that, they usually use they give a heating treatment. Sometimes they make that body hot, and then it is easy to, it becomes little flexible, the muscles and all relax a bit, so that they use infrared radiations. Now the question is, so that means, are infrared radiations not dangerous for human skin? No, but a high dosage can cause skin burns, of course. Okay, it's like any heat thing, that it can cause burns. Okay, and also they are used in remote control of television and other gadgets. So in the front of the remote control you have a red bulb, that's an infrared light. Again, when you press it, you won't see the light going, but it will yeah, it does its work fine. So distinction between ultraviolet, visible and infrared, you can go through it, it will give you a comparative study of all the three types of radiations. Okay, and then the homework for today will be to write the reasoning questions. Okay, you have to write the answer for question number 28. Write the answer for question number 28. All the reasoning questions, 1, 2, 3, 4, 5, 6. So mostly from this part, only reasoning question comes. Okay, so write it and send it to me today itself. Thank you, children.